Hi, my name is Ruth Kim, and I'll be talking about the fermentation of milk into yogurt. So yogurt is one of the most widely consumed fermented dairy products around the world, with about 15% of global yogurt production based here in the US. Yogurt is a thick, creamy, tangy milk product that can be made from a variety of milks, from cows, goats, and buffalo. And nowadays we even see some yogurts being made from a variety of plant-based milks, such as coconut milk yogurt. As some of these images illustrate, yogurt can be enjoyed in a variety of ways, such as in a savory dip, like in tzatziki, which is a Greek yogurt dip, or raita, which is an Indian yogurt sauce, and of course many of us have enjoyed a little sweet snack of the yogurt parfait at some point. The origins of yogurt are largely unknown, but are thought to date as far back as 5000 BCE. The story goes that when ancient Mesopotamian herdsmen would travel, they stored milk in canisters made from animal skins. The warm environment and limited oxygen supply in the canisters, as well as the presence of lactic acid bacteria, likely provided the favorable environment for fermentation to occur and transform the milk into a thick, tangy, slightly sour form, which we now know to be yogurt. This was significant because it provided a way to preserve milk for many ancient civilizations. The process to make yogurt starts with collecting milk from dairy farmers and testing the quality of that milk to determine the fat content, as well as ensure that it is free of any antibiotics that could hinder the fermentation process down the line. Once the milk quality has been assessed, milk solids, stabilizers, and/or cream can be added to adjust the composition of the milk based on what the final desired consistency and fat content of the yogurt is. The mixture is then pasteurized, heated to a temperature of about 85 degrees Celsius for around 30 minutes to sterilize the milk and kill off any bacteria or microbes that could be harmful to consumers. Next, the mixture is homogenized using a high-pressure piston homogenizer, which breaks up and normalizes particle sizes so that the end product is smooth and consistent. The mixture is rapidly cooled to about 43 degrees Celsius, and a starter culture containing necessary lactic acid bacteria to ferment the milk is added to the mixture. The milk mixture is then transferred to fermentation tanks for bulk fermentation, incubated at a temperature of about 43 to 48 degrees Celsius to promote the growth of the thermophilic lactic acid bacteria. The fermentation process as a whole takes about 4 to 7 hours to complete, or until the pH reaches about 4.5. Finally, the yogurt is cooled to 4 degrees Celsius to stop the fermentation process and store the final product. After this point, the yogurt can either be flavored or packaged directly and distributed. The final count of CFU per gram of yogurt is done before the yogurt is shipped off. Most countries often require a minimum of 10 to the 6th CFUs per gram for yogurt to be approved for distribution. The starter culture used to ferment milk to yogurt usually consists of 2 main lactic acid bacteria, though others may also be added for flavor or other reasons. Streptococcus thermophilus and Lactobacillus buergericus subspecies Delbrueckii are the 2 facultative thermophilic bacteria that are responsible for fermenting milk to form yogurt. So these two form a symbiotic relationship where Streptococcus thermophilus breaks down the lactose found in milk as its main carbon source during fermentation. Because it is a homolactic bacteria, S. thermophilus also releases lactic acid as a byproduct, which is responsible for dropping the pH of the milk to give yogurt its signature tang and help coagulate milk proteins to make the yogurt thicken. However, S. thermophilus is non-proteolytic, meaning that it needs a source of simple amino acids to grow because it can't break down proteins on its own. And that's where L. bulgaricus, subspecies Delbrueckii, comes in. So L. bulgaricus breaks down milk proteins, mainly casein, into amino acids for S. thermophilus to use to grow. And in return, L. bulgaricus is able to thrive in the low pH environment enabled largely by the S. thermophilus growth. The main conditions altered to affect microbial growth in yogurt production include acidity, oxygen availability, temperature, as well as time. And in addition to that, the just intrinsic nature of the food itself. So as with most fermentation methods, incubation is largely set in an anaerobic environment which promotes fermentation of the milk by the facultative bacterial started cultures. And the low pH developed in the yogurt not only inhibits the growth of many other microbes and pathogenic microbes, but it also helps to control the overall growth of lactic acid bacteria, the ones responsible for fermenting the yogurt as a whole, thereby controlling the overall microbial load of the food itself. And the pH is normally regulated and tested before distribution using pH meters, as this illustration shows to the right. Additionally, the high incubation temperature during fermentation favors the thermophilic lactic acid bacteria responsible for fermenting the yogurt over any other bacterium that may be pathogenic, as pathogenic bacteria are often found to be mesophiles and do not typically grow at the high temperatures that are seen in this incubation of yogurt. So the high incubation temperature prevents most pathogenic bacteria from growing, as it's above their optimum growth temperature range. These factors that are altered to favor the growth of the lactic acid bacteria allow for the fermentation to occur in a relatively short amount of time, thereby lessening the amount of time that microbes may have to access or contaminate the product. Other factors that affect microbial growth in yogurt include the intrinsic nature of milk, that lactose is the main sugar found in milk and thus selects for the growth of microbes that are able to readily break down lactose sugars for energy over those that maybe are not able to break down lactose or use it in their metabolism. And that's about it. Hopefully you enjoyed this little presentation and are able to really enjoy and appreciate all of the yogurt that you consume now and in the future to come. So, thanks so much for listening.